Chapter 1. Right, I need to simplify these fractions. In 1a, I'm going to divide top and bottom by 3x. I'm not going to worry to factorise the top here. I'm simply going to divide all the terms by 3x. It's going to leave me with x cubed minus 7. B. Right, I can't easily see factors of top and bottom here, so I'm going to factorise the top and factorise the bottom, and then I'll know what divides into the top and the bottom. The top factorises to x minus 6, lots of x plus 4, and the bottom is going to be a minus and a 6 and a 1. So I can see that I can divide the top and bottom by x minus 6, leaving me with x plus 4 over x minus 1. And 1c now. Again, I can't easily see what goes into top and bottom, so I'm going to factorise the top. When I factorise the top, it's obviously going to be 2x and an x. Now, I can see that I'm going to have a positive and a negative. I need to multiply to 4. I'm going to have plus 4 here. It gives me plus 8x's, and then minus 1 there to give me minus an x to give me plus 7 in all. Now, when I factorise the bottom, I know it's going to be 2x and x again. This time they're both positive, multiplying to 4. 2 and 2 won't work. 4 and 1 will, however. And now I can divide top and bottom by x plus 4, leaves me with 2x minus 1 over 2x plus 1. And that is question 1 complete. Question 2. I've got to divide this polynomial by x plus 4, so I'm going to use a long division method here. X into 3x cubed goes 3x squared times 3x squared times x plus 4, 3x cubed plus 12x squared. Subtract, leaves me with 0 here, plus the 5x. X into 0 goes 0, so I'm going to need 0 x's. Multiply by 0, multiply by 0, minus and minus, leaves me with 5x, drop the plus 20, x into 5x goes plus 5 times x plus 4 is 5x plus 20, leaves me with no remainder. So my answer is that polynomial divided by x plus 4 is 3x squared plus 5. Question 3. I'm asked to simplify this fraction. Now, I'm assuming that x plus 1 will divide into that polynomial on the top. So I'm going to write down the polynomial on the top and do a long division to find out what the polynomial on the top divided by x plus 1 is. And when I write it down, I'm going to write it down with 0x squareds, because that will make my long division sum work more easily. Okay, here we go. So x into 2x cubed goes 2x squared times x plus 1, 2x cubed plus 2x squared. Subtract. Minus 2x squared, copy down the plus 3x. X into minus 2x squared goes minus 2x times x plus 1. Minus 2x squared, minus 2x, minus signs in there. 3x minus 2x is 5x. Copy down the plus 5. X into 5x goes plus 5 times x plus 1 is 5x plus 1. No remainder. So I know that x plus 1 goes into the numerator there that many times. So my fraction simplified is simply going to be 2x squared minus 2x plus 5 over 1, which is 2x squared minus 2x plus 5. And that's question 3 finished. Question 4. Show that x minus 3 is a factor of this polynomial. Well, to do that, I'm going to divide the polynomial by x minus 3 and show that there's no remainder. So x into 2x cubed goes 2x squared times x minus 3 is 2x cubed minus 6x squared minus and minus. Minus 2x squared minus 6x squared, 4x squared. Copy down the minus 17x. X into 4x squared goes plus 4x times x minus 3. 4x squared minus 12x. Minus and a minus 17x minus 12x minus 5x. Copy down the plus 15. X into minus 5x goes minus 5 times. Minus 5 times x minus 3 is minus 5x. Minus 5 times minus 3 is plus 15. There's no remainder. So I have shown that x minus 3 is a factor. Part B, hence express this polynomial in this form, where I need to find a, b, and c. Well, that polynomial, which I'll call f of x, must equal x minus 3 multiplied by 2x squared plus 4x minus 5. And so where the values of a, b, and c are to be found, well, I found those. It doesn't ask me specifically what they are, but a is 2, b is 4, and c is minus 5. And that's question 4 finished. Question 5. I've got to show that x minus 2 is a factor of that polynomial. So I'm going to factorize the polynomial by inspection. So x minus 2, so I'm going to need to have an x squared there to give me the x cubed. That's going to give me minus 2x squared, and I want plus 4 of them, so I'll need 6 more. That's going to give me minus 12x, and I want minus 3x, so I'm going to need to have 9 more. And let's just check that the minus 2 times the plus 9 does give me minus 18. Yes, it does. What was the question here? Show that x minus 2 is a factor of it. Well, I have done, because I've shown that my polynomial can be written as x minus 2 multiplied by something. Part B. Hence express the polynomial in the form x minus 2 px plus q squared. All right, let's have a look. So far, my polynomial, which I'll call f of x, is x minus 2 multiplied by x squared plus 6x plus 9. Can we factorize that any further? Yes, we can. X minus 2, and that second bracket is simply x plus 3 multiplied by x plus 3, which is, of course, x minus 2 multiplied by x plus 3 squared. Now, it says, write the polynomial in the form x minus 2 lots of px plus q squared. Well, I've got to find p and q. Well, I've done that, and p would be 1, and q would be 3. And that is question 5 complete. Question 6. I need to factorize this expression completely. So the first thing I'm going to need to do is to find a factor of that expression. So I'm going to use the factor theorem to do that. I'm going to explore first whether or not x minus 1 is a factor. So I'm going to evaluate f of 1 and see if that equals 0. When I'm evaluating f of 1, of course, I can just use the coefficients. So I'm going to have 2 plus 3 minus 18 plus 8. How frustrating. That does not equal 0. Let's try f of minus 1. Well, that would be 2 times minus 1 plus 3 plus 18, because minus 18 times minus 1 is plus 18 plus 8. That's not equal to 0. Okay, let's try f of 2, shall we? Okay, so that's going to be 2 times 2 cubed is 8, plus 3 times 4, minus 36 plus 8. That's 16 plus 12 minus 36 plus 8. I reckon this is going to work. That's 28 minus 36 plus 8, which is 0. So I know that f of 2 equals 0, which means that x minus 2 is a factor. Right, now I'm going to write that red expression as a product of x minus 2 and something. And I'm going to do that by inspection. X into the 2x cubed would be 2x squared. That will leave me with minus 4x squared, and I want plus 3 of them, so I'll need another 7. That gives me minus 14x, and I want minus 18, so I want another minus 4. Final check, minus 2 times minus 4. Yes, that is plus 8. Good. Right, factorize it completely, it says, so I bet that I can factorize it one step further. Can I factorize that second bracket anymore? Well, it's going to have to be 2x and x. Now, it's a minus 4 and a plus 7, so it's going to be a plus and a minus there. I have to multiply to 4. 4 and 1, I'm thinking, or more to the point, 4 and minus 1, because that will give me plus 7x. Now, let's just check the question. Factorize that completely? I have done. That is my answer to number 6. Question 7. Find the value of k if x minus 2 is a factor of this polynomial. Right, well, according to the factor theorem, if x minus 2 is a factor, then I know that f of 2 will be 0. So let's work out the value of this function when x is 2. It would be 8 minus 3 times 4 plus 2k minus 10. And I know that has to equal 0. Okay, well, that's 8 minus 12 minus 10 plus 2k. So that is minus 14 plus 2k equals 0. So 2k is 14, and k must therefore be 7. Find the value of k. If that is a factor, job done. Question 7 is complete. Question 8. I'm given a function of x, and I'm told that when x is minus 3, my function equals 0. And I'm also told that when x is 4, the value of the function is 21. Let's use each of those two pieces of information. First of all, if x is minus 3, then my function is 0. Well, if x is minus 3, then my function equals 2 times minus 3 squared, which is 2 times 9, plus, I beg your pardon, minus 3 times p plus q. So that's going to give me an equation in p and q. Minus 3p plus q equals minus 18. Okay, let's use this piece of information. If x is 4, then the function has a value of 21. So that's going to be 2 times 4 squared, 2 times 16, plus 4p plus q, and that has a value of 21, which is going to tell me that 4p plus q equals minus 11. Okay, now I've got two equations, look, in two unknowns, p and q. So I'm going to solve those equations simultaneously to find p and q. Let's copy down those equations. 3p plus q equals minus 18, and 4p plus q equals minus 11. Right, well, both equations have got the same number of q's in them, so I'm going to subtract one equation from the other. I'm going to subtract the bottom one from the top. So that's going to give me minus 7p. The q's are going to go equals minus 18 minus minus 11 is minus 18 plus 11 is minus 7. So p must be 1. Okay, and I'm going to substitute that into one of the equations. I'll use the top one. Minus 3p plus q equals minus 18. P is 1, so minus 3 plus q equals minus 18. Plus 3 to both sides. Q must equal minus 15. Now let's just review the question. Part A says find the value of p and q. So my answer for A is that p equals 1 and q is minus 15. And part B asks me to factorize f of x. Well, let's first of all, for part B, write down what f of x equals. Now we know p and q. So f of x is going to be 2x squared plus px is 1x, x, minus 15 plus q, and q is minus 15. And I'm asked to factorize that. I wonder if I'm given any more clues. Well, I know already that f of minus 3 equals 0. So that tells me already that x plus 3 is a factor. Okay, so I should be able to use that to help me now to work out the second factor. And now I'm going to need a 2x here, so they end up with 2x squared. And now I'm going to need a minus 5 there, so the plus 3 and the minus 5 together give me minus 15. And let's just check that that does give me plus an x, and it does, because I'd get plus 6x there and minus 5x there. So there you go, I've factorized the expression completely, and that is question 8 finished. Okay, question 9. Right, we've got a function h of x, and we know that the value of the function when x is minus 1 is 0, and we know that the value of the function when x is 2 is 30. So let's use those two facts to help us. When x is minus 1, my function is minus 1 minus 4 minus r plus s, and I know that equals 0, which gives me the equation minus r plus s equals 5. When x is 2, then h has a value of 8 minus 4 fours, that's minus 16, plus 2r plus s, and I know that equals 30. So I know that 2r plus s equals 38. Great. Now I've got two equations and two unknowns. Here's my first equation, and here's my second equation. So I'm going to solve these simultaneously to find r and s. I'm going to do, they both got the same number of s's, so I'm going to subtract the equations. Top one minus the bottom one gives me minus 3r equals minus 33. So r is 11. Now I know that r is 11. Presumably I can find s, perhaps by using this equation. Minus r plus s equals 5. Minus 11 plus s equals 5. S equals 16. So I found r and I found s. R equals 11 and s equals 16. So that's part A done. Next question, can I factorize h of x? Well, of course, I can now take h of x and I can tell you what it equals without those r's and s's in the way. H of x is x cubed, I'm copying down this red expression, minus 4x squared plus rx, and r was 11, so plus 11x plus s, which is 16. So that's what h of x equals. I'm being asked to factorize that. But I do know that h of minus 1 is 0. So I know that x plus 1 is a factor. So now I can use that piece of information to factorize this expression here. I'm going to factorize it by inspection. So I've got x plus 1 multiplied by something to give me this expression here. So x plus 1, I'm going to need an x squared there. That gives me plus 1x squared. I need minus 4, so I'm going to need minus 5x's. That gives me minus 5x's. I need plus 11, so I'm going to need to add 16. Just check. 1 times 16 is 16. Now, can I factorize it any further? Well, I'm imagining that I'll be able to factorize that second bracket a bit more. It's obviously going to be x and x. It's going to be 2 minuses, isn't it? Because I've got a minus and a minus. Do you know? I don't think I can factorize that anymore. So, I'm not going to do that, but I've tried, and I'm going to conclude that h of x is x plus 1, lots of x squared, minus 5x plus 16. And that is my answer to number 9. Number 9. I've got an expression h of x here, a polynomial, and I know that when x is minus 1, the value of h of x is 0. And I know that when x is 2, the value of h of x is 30. So I'm going to use both of those pieces of information. So when x is minus 1, I would have minus 1 plus 4 minus r plus s, and that equals 0, which means that minus r plus s will be minus 3. And when x is 2, then I would have 8 plus 16 plus 2r plus s, and that will be equal to 30, which means that 2r plus s is equal to 6, taking 24 off both sides. Now I've got two equations in two unknowns. So I'm going to solve those simultaneously. I've got minus r plus s equals minus 3, and I've got 2r plus s equals 6. I'm going to subtract the equations because I've got the same number of s's in both equations. It gives me minus 3r equals minus 9, so r equals 3. How will I find s now? Well, I'll use the top equation. I've got minus r plus s equals minus 3, and so that's minus 3 plus s equals minus 3, so s equals 0. So I found out now that r is 3 and s is 0. Okay, that's part A done. Part B, factorise h of x. Okay, well now I know, let's do part B up here. Now I know that h of x is x cubed plus 4x squared plus rx, and r is 3, plus 3x plus s, but s is 0. So actually I'm just factorising this expression here. Well, I can take out an x squared plus 4x plus 3, and then I can simply factorise that just by looking at it really. It's x plus 3, lots of x plus 1. So I didn't in the end need this information here, that x plus 1 was a factor, because it was clearly obvious just by looking at the function h of x. Right, that is question 9 done. Number 10, right, I've got an expression g of x, and I need to factorise it first. So I'm hunting for factors of this expression here. I'm going to try x is 1. Now, just before we get started on what to try, it's a good idea to think what's sensible to try. You know that this is a cubic, so it's likely to look something like this. And you know you're going to have a constant, a constant, and a constant. And you know they have to multiply to give you minus 5. Well, there's probably going to be a 1 there, or a minus 1, because there's a limit to how many integers can multiply to 5. So I'm going to try, first of all, and evaluate g of x when x is 1. It's going to be 2 plus 9 minus 6 minus 5. Aha, that is 0. So that means if g of 1 is 0, then I know that x minus 1 is a factor. So I'm going to use that now to start factorising g of x. So I've got g of x, that's the red expression, and I'm going to be looking at the red expression and factorising it by inspection. X goes into 2x cubed, 2x squared is what I'm going to need there, isn't it? Now I'm going to have minus 2x squared, so I'm going to need to have another plus 11 of them. Now I'm going to have minus 11 of them, so I'm going to need to have minus 11x, and I want to go to minus 6. I'm going to need to have plus 5, and final check, minus 1 times plus 5 does give me minus 5. So that's g of x factorised there. I'm imagining I'll be able to factorise it a bit more. Obviously it's going to be 2x and x. It's going to have to be 5 and 1, isn't it? It's certainly a plus and a plus, and it's a 5 here and a 1 here to give me the 11 x's. So there's g of x factorised for part A. And part B, the question is solve g of x equals 0. Well, if g of x equals 0, then I know that g of x factorised is this expression. So if g of x equals 0, then that expression equals 0, in which case x must be 1, or minus a half, or minus 5. And that is question 10 sorted.